Hi. So watsonx is an enterprise-ready data and AI platform built for enterprises, and it comes with three components: watsonx.ai, your traditional AI and generative AI studio with foundation models, prompt engineering labs, and watsonx.data is a fit-for-purpose data store used to scale all your data and AI workloads. And it also comes with a governance toolkit that enterprises can use to track their AI use cases, models, detect biases, and this is used to ensure responsible, transparent, and governed artificial intelligence. And for the demo today, we're going to look at how we can create AI use cases, how to manage the life cycle of our models using watsonx.governance, right? And how we can track these models and ensure transparent, governed use cases for both traditional as well as generative AI models. And for our first step, we are going to look at how we can identify a model inventory. And the watsonx governance allows organizations to group and track their models based on use cases or the issues that our organization is trying to solve. And each use case actually stores and organizes not just the data, but the entire life cycle information for the candidate models. And these use cases are in fact stored as assets in the model inventory. In fact, I had already created an inventory, put in a use case and run it through, but the access to model inventory is actually required to complete this lab. Since I had already created an inventory, we're not seeing it here, but basically you would in fact be directed to a place where you can manage your inventories, create new inventory and associated with an object storage instance. In fact, it is very straightforward. Now that we have the inventory set up, let's create a use case for a predictive risk model. And in this case, basically an insurance company would like to assess the risk associated with auto insurance policies, and the data science team that they have has gathered various accident hotspots, right? And as part of the first process, the stakeholders in the company, the business team, the data science team would like to create a use case policy. So let's create a new AI use case. Okay, so AI use case, let me type auto insurance predictive model. Okay, description, test. Okay, owner, status, draft. Okay, tags, yeah, create. Hi, so the AI use case that we have created, we are in the overview section, and while creating that particular AI use case, I had the option to change the status and put in the risk level, but since we didn't do that there, we can do that here as well. Okay, draft, let me change it to development in progress, and risk level, okay, let me put it as medium. Tags, what's the model purpose, any supporting documentation, business or technical documentations that you have, the risk level, attachments, everything you can gather it in the overview tab. So we have successfully created a use case, in this case, an insurance company creating a predictive model for auto insurance to address a specific business need. Now what we'll do is we will create a watsonx project that will contain all the assets that are used to deploy and work with the model. So watsonx provides a central location, not just for your data scientists, engineers, or subject matter experts, but the business stakeholders to work on, collaborate on data science and AI projects. And this particular lab only uses a few of its capabilities, uh, uh, but other capabilities in terms of easy connections to different types of data sources, drag and drop, visual model building, easy data manipulation with IBM SPSS, prompt engineering, synthetic data, all these capabilities are present. So let me just work on creating a new project. So for the auto insurance use case that we're building, I do have a sample file. So I will click on create a project from sample.file, and we can easily upload a zip file that can contain an exported Watson Studio project, right? So let me just name this particular project auto insurance. I think it's a Chicago data set. Yeah, Chicago. Okay, test. So I have the file already. You can mark it as sensitive. Also, if it's sensitive, let me just upload the zip file that I have downloaded on my system, right? Okay, auto insurance policy. Okay, this project, actually the environment that I have created includes integration with the cloud object storage for storing all our project data sets. So now that we have created an AI use case, we are creating a project to associate that. So let me click on create. Okay, so let's wait for the project to get created. So auto insurance, the project has been successfully created. Now we can go and access its asset. I just wanted to say a point that while it does say that the resources has imported successfully, you should go and click on view import summary to ensure that nothing is listed in the incomplete or failed category, right? So let me go and view this new project now. So the successfully created auto insurance Chicago project, I have the overview. We can add collaborators, data science business teams, add live data to work with, choose a appropriate foundation model and build prompts. But let's check if the assets that we did import, yes, we can see that, the zip file that we have, the assets has been created. Once the project has been created and the AI use cases associated with it, we have to manage the associations and associate a machine learning service. So I have in fact already done that. Or in case you want to add a light assistant, light version or enterprise version of machine learning, you can associate that particular service as well. Okay. Once we have managed the associations and associated machine learning service, now we will track this model, right? And this particular lab will use a model that is built with Auto AI. And Auto AI is IBM's rapid model prototyping service that can quickly generate predictive machine learning models from tabular data, and we can save the output as a Jupyter notebook. And we have already clicked on assets. Now let me, from the list of assets, let me click this Auto AI policy risk and open the model information screen. Now let's take a moment to review the information presented. As you can see, this information can be exported as a PDF, and the metadata that we see includes when the model was created, the identity of the creator, the prediction type, the algorithm that was used, the model type, the software specification. Let us go to the training metrics, right? Number of features, hybrid type pipeline, and as the regulations around use of AI and both traditional and generative models increase, the ability to automatically track and easily retrieve this model metadata without the manual effort of your data science or their AI developers is very crucial. And as you can see, watsonx provides this capability, improving the transparency across various stages and helping speed up the time to value. Okay, now it's our job to track this particular auto AI policy risk E4 rich model. Track this model. Okay, auto insurance predictive model. Next, default. Let me leave it as default version. So I will leave it as experimental version, and this will be used as a starting point since our model is currently in the development stage and its input and output structure. As this model goes through changes, it will probably change in the near future. So we'll keep it as experimental. And let's review this, right? Auto insurance predictive, creator Venkatesh. Define the AI use case. Yes. Back, back, back. Okay. Track asset. Just a quick summary, we first created an inventory to store all our AI use cases, and we created an AI use case, created a project to store all our data sets to associate with this particular AI use case. Then the model that is created by Auto AI, we have enabled tracking. And now that the model tracking has been enabled, we have the model information screen. Now let's click open in AI use case button. So a new tab is opening in our browser. So in the AI use case window, we had already seen the overview, but now that the model has been tracked, let's go to the lifecycle tab. And if you scroll down to the map of the models contained in the default approach, as you can see, there are 4 stages, right, in the lifecycle, that is develop, test, validate, and operate. And the tracked model has not yet been promoted to the deployment space. So it is currently listed in the develop section. And if you click on the model name from the screen, you will see the full model information that we saw previously. And the lifecycle tab of the AI use case is useful for not just your technical stakeholders, but also your business users to get a quick snapshot and overview of the models attempting to address a particular issue, which is in this case an auto insurance policy. And we can drill down for more information as necessary without needing to access the project where the actual data developers and data engineers are working. So we have successfully enabled model tracking after creating AI use cases, adding inventory, creating a project. Now and we can now observe as a high level from a eagle standpoint, observe the changes as the model goes through its entire life cycle from develop to test to validate to operate, and you actually realizing its value. Next, let's work on promoting this particular model into the deployment space, and let's deploy it. And watsonx actually uses deployment spaces to organize all our models and model related assets for our validation and access to production. And deploying the model allows it to be accessed via REST API for further testing. Let's move back to the browser. Let's move back to the projects, and you can subsequently view this project from the browser tab as well. But since I have this browser open, let's go there, right? So at this particular stage, we will create a new deployment space to contain the models, and since it's just one model right now, but note that you can also use an existing space as long as it is tagged with the correct lifecycle phase specified in the creation directions. Let me promote it to a new deployment phase, right? Okay, create a new deployment space. Deployment space name Venkatesh testing. Description test. Deployment stage, let me put it under testing. Deployment space tag optional. Storage is automatically configured. Machine learning service. Yes. Let me review it. Yes. Let me click create. Okay. The space is getting created. The successfully created space now will appear in the target space drop down, and we can click the checkbox next to the go to model into the space after promoting it. Yes, let's click this checkbox and let's click on promote. So as you can see, the deployment space screen has been loaded with the entry for the model put in. Yes, 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 yes. Yes, so the model has been successfully promoted to space. So deployment spaces can contain different type of assets, just like your projects, including the models themselves, as well as the data that is used in the processing jobs. And spaces are fully governed, allowing your administrators to provide different levels of access for your different stakeholders. And the models in space can have both online as well as batch deployments created that allow access to the model. So what we'll now do is click on the new deployment button and create a new deployment. Since our plan is to access this model through REST API access, we will click on the online tile, which is already selected. Let's give our deployment name, name Venkatesh, testing, serving name, description, tags, okay. And let's click on the create button. And I think deploying this model will take roughly a minute. So for this particular deployment Venkatesh testing, I had used the same machine learning instance that I had used 3 days ago. So since it was a live instance, I don't think it can be promoted to more than deployment space. But when the deployment is finished, the status is displayed and it will change to deployed. So let me take you through the space that has already been deployed 3 days ago, that is testing. So please note that this is the same exact model that has been tested previously, just the name and the model parameters, the creator dates is changed. So I see one deployment. Let me go to the auto AI policy. Okay, let me click on the test deployment. Okay, so as you can see, the details that are given in the API reference tab include direct URLs to the model, and as well as the code snippets in a variety of programming languages from Perl, Java, JavaScript, Python, and Scala. And this allows your application developers to seamlessly include this model in their end applications. So the test tab allows for direct testing of the model using either uploaded CSV files or your JSON output. Let me click on the deployment details. Okay, model is being tracked. Deployment space, deployment ID created, deployment type, scoring endpoint. Yeah, let me just open this in the AI use case. And let's go and click on the lifecycle tab. Okay, so as you can see, there is now an entry for the model in the test section, the model lifecycle view with a badge showing that evaluation is pending, right? So pending evaluation. In this case, the model connection can be tested by the application developers, as we saw through any programming language, as well as the data science team, to ensure that it is functioning properly and accessible. So the next step, what we'll do is we will validate that the model is making fair, accurate decisions. For evaluating the model's quality, bias, fairness, we will use IBM OpenScale. So Watson OpenScale is a platform that helps us operationalize the AI models. So it's an enterprise-grade environment that tracks and measures the outcomes of the AI models. And as we are looking at this lab, it also helps us ensure that the models are fair, explainable, and compliant. And for first step, we are going to configure the deployment space for monitoring the deployment space that we had created for the auto insurance policy. Let me click on system setup. Yeah. Okay. So required database. I see a DB2 DB configured. Let me go to the machine learning provider. Yes. Add machine learning. New provider. Testing. Auto. Apply. Connection. Machine learning version 2. Deployment space. Testing. Pre-production. Save. So now the deployment space has been identified as a ML provider for the monitoring service. Now we have to configure the monitoring for the model itself, where I will go to the insights dashboard, and now let's do add to dashboard, right? Okay, so let me find the deployment space. Testing out of, okay, next, test, next, provide model information, yes, numerical data, algorithm type, regression, model endpoint. Let me go and view the summary now. Deployed model test, yes, numeric regression, risk, the feature columns, categorical features, prediction column, this information is accurate, yes. Let's click on finish. Okay, so after a brief wait, the metrics overview screen for the model will open. Now that this has been done, we will gather the necessary information for the model, right? We will configure monitoring for the model, and this will require sending some data into it, which in turn requires some information about the model subscription in the monitoring service. Usually this step wouldn't be required. However, we will be monitoring the model for indirect bias. And as I said, this would require us sending some metadata to the model that is not included as a feature. For evaluating the model's quality, bias, fairness, we will use IBM OpenScale. So Watson OpenScale is a platform that helps us operationalize the AI models. So it's an enterprise-grade environment that tracks and measures the outcomes of the AI models. And as we are looking at this lab, it also helps us ensure that the models are fair, explainable, and compliant. And for first step, we are going to configure the deployment space for monitoring. The deployment space that we had created for the auto insurance policy. Let me click on system setup. Yeah. Okay. So required database, I see a DB2 DB configured. Let me go to the machine learning provider. Yes. Add machine learning. New provider. Testing. Auto. Apply. Connection. Machine learning version 2. Deployment space. Testing. Pre-production. Save. Right. So now the deployment space has been identified as a ML provider for the monitoring service. Now we have to configure the monitoring for the model itself, where I will go to the insights dashboard, and now let's do add to dashboard, right? Okay, so let me find the deployment space. Testing out of, okay, next, test, next, provide model information, yes, numerical data, algorithm type, regression, model endpoint. Let me go and view the summary now. Deployed model test, yes, numeric regression, risk, the feature columns, categorical features, prediction column, this information is accurate, yes. Let's click on finish. Okay, so after a brief wait, the metrics overview screen for the model will open. Now that this has been done, we will gather the necessary information for the model, right? We will configure monitoring for the model, and this will require sending some data into it, which in turn requires some information about the model subscription in the monitoring service. Usually this step wouldn't be required. However, we will be monitoring the model for indirect bias. And as I said, this would require us sending some metadata to the model that is not included as a feature. I'm in the model metrics page, and now I'll be clicking on actions, view the model information. So for this particular lab, I'll be copying the evaluation data mart ID and subscription ID onto a notepad, and this will be later used to pass information to a Jupyter notebook. So yes, evaluation data mart ID, subscription ID, yes. Now that this is done, we will go to the different browser window, in this case the watsonx page, and navigate to the cloud API keys page, right? Okay, access IAM. API keys. Now let's create an API key. Okay. Test, open scale, auto insurance, right? Create. So we can copy this API key onto the same notepad. Let me also download the same.